again, I'm here from SACRM to discuss, you've guessed it, Fibonacci, the golden ratio, divine proportions, and all of these concepts which are all related to one another. Before beginning this episode, I wanted to start by highlighting that what I say in this episode and throughout the series is all scientifically backed, and that the nature of science is that it is ever evolving, so what I say today is based off what the current scientific literature supports, and is by no means encompassing of what true beauty is. My aim is to shed some light on the different aspects of life that seem to appear to us as beautiful or attractive. So without further ado, the golden ratio, also known as Phi's constant, is an irrational number which can be approximated by 1.618033988749895. Thank you, see you again tomorrow. Now that I've had a small laugh, let's try to tackle what the golden ratio actually is and how we can use it to better understand beauty. For this, I thought it would be best to give you all some background context on what the Phi constant is, how this ratio relates to the Fibonacci sequence, and in turn, how both of these can relate to beauty. Next, I'll explain how the golden ratio has been scientifically applied to the face, and finally, we need to talk about the problems and drawbacks to using divine proportions as a standard of beauty. If you want a really in-depth explanation of Phi's constant and nature and its mathematical interpretation, it can be found below in the link in the description. For all other people who want a quick rundown of what this number is, I found the best way of describing it is by using two identical lines. We'll call the length of line 1 the sum of A and B, and we'll split line 2 into A and B respectively. However, the way we're splitting these lines is special because we want the change from the sum of A and B to A to be proportional to that of A to B. And that can only be found at one specific point, which is the golden ratio or Phi's constant, also known as 1.612, etc. If we were to apply this to a painting like the Mona Lisa, for example, you'd see that the height of the painting is 1.612 that of its width. Does that explain why the painting is so sought after? Probably not. But we can surely see that there must be some association between what humans find beautiful and this number. The Fibonacci sequence is another numerical function which can provide you with the elusive Phi constant. The premise is simple. You start out with the number 0 and 1. And every next number in the sequence is the sum of the previous two numbers. So 0 and 1 is 1. 1 and 1 is 2, 2 and 1 is 3, and so on. What's interesting is when you get to 5. You can divide 5 by 3, the previous number in the sequence, and you'll get 1.666 recurring. Go further still and you'll get 8 over 5, which is 1.6. 13 over 8 gives you 1.625, and then you can probably see where this is going. The further along the number is in the sequence, the more closely this ratio comes to the golden ratio. So how does this relate to beauty in art? Well, oftentimes photographers or artists will organize a painting or a piece in a specific fashion so that the subjects in the piece follow this pattern. We also see these patterns on seashells and sunflowers and many other aspects of nature. And even go so far as to use this golden ratio to dictate what ideal proportions look like. A computer-generated example of this is a Marquise mask. However, this method of assessing beauty is not without its faults. Studies have shown that the nature of this design of the mask makes it naturally more favorable to Eurocentric and Caucasian proportions, meaning that at least the current Marquise mask design is not as well suited to measure universal beauty. Studies have suggested making modified versions of this mask for different ethnicities, but this is still to be implemented. What can be said though is that there are studies which clearly highlight that when comparing conventionally attractive faces with controls, there was a significant correlation between the attractive group's faces and the Marquise mask. Still, more research and innovation is required to truly grasp the relationship between computer-generated divine proportions of our face and bodies and beauty itself. All this talk about numerical valuations of beauty can be quite misleading to an unadulterated mind. As Shu-Kun Lin in a paper published in the International Journal of Molecular Sciences puts it, symmetry is beautiful because it renders stability. On the other hand, asymmetry is beautiful because it overcomes stability and drives evolution and the generation of complexity. In other words, symmetry builds perfect, beautiful shapes, but it is the asymmetry that confers the charm of a dynamical nature. And how does this relate to the golden ratio, one may ask? Well, as you may know, the phi constant is an irrational number. Irrational numbers cannot be divided into units of 10, but some can still be divided into units of 3 or 9, such as 1/3 or 0.3 recurring. What's special about phi constant is that there is no way to divide this number perfectly. It is the most irrational number, so to speak. Therefore, I believe this is the number where asymmetry meets symmetry, motion meets stillness, imperfection meets perfection. The silver lining. To summarize what we went over today, we talked about the phi constant and how to derive it from geometry and the Fibonacci sequence. We also talked about how the Fibonacci sequence seems to play an important role in aesthetics and its relationship to art, photography, and architecture. Next, we went over divine proportions and the market mask and the drawbacks of this method of assessing beauty. Lastly, we talked about how the golden ratio seems to be the missing link between symmetry and asymmetry. That's all for today. Thank you for tuning in to the second part of our web series, and be sure to like, comment, and share if you liked what you saw. It really would mean a lot so we can gauge what you guys think. Till next time.